Hello and welcome to this webinar on the exciting new features in nRF Connect SDK version 1.6. This is a part of the Mobile World Congress Experience 2021. I'm one of your hosts today. My name is Bjorn. I'm a product marketing engineer at Nordic Semiconductor, and with me I have Christoph and Joachim. They are both technical product managers. Christoph works on the short-range wireless side, and Joachim works with our cellular IoT products. So just some quick practicalities. The duration of this webinar will be approximately 45 minutes, and we'll have a 15-minute Q&A at the end. Questions are encouraged. Please type the questions in the top of the right sidebar. You should see Ask a Question. All questions are anonymous. Please try to keep them relevant to the topic, and then we will answer the questions towards the end. The chat on the bottom right-hand corner is not anonymous and should not be used for questions. If you do have any more questions after the webinar is done, feel free to go to Nordic DevZone. And last but not least, the recording of the webinar together with the presentation as a PDF file will be available at webinars.nordicsemi.com/on-demand at the end of the webinar. So just a quick agenda before we get started. I will go through a short intro to the nRF Connect SDK and some basic terminology. That should take roughly 15 minutes. And then I'll hand it over to Christoph for short-range updates in nRF Connect SDK version 1.6, and then Joachim will talk about the Cellular IoT updates in nRF Connect SDK 1.6. And last but not least, we'll have a 15-minute Q&A at the end. So communities, we do have a lot of webinars that you can watch. If you go to nordicsemi.com/webinars or webinars.nordicsemi.com. So a lot of good technology intros to the different technologies we provide and trainings. We, of course, also have the Nordic Developer Zone. That's devzone.nordicsemi.com. It's our tech support center and online community. As of right now, we have more than 29,000 users, more than 60,000 posts with questions and answers, and 3 million page visits in the last 6 months. And last but not least, we have the Nordic GitHub. There we have 121 different repos, mainly written in C and C++, but we do have some Python and JavaScript repos too. And that's where we provide a lot of source code for free. And that's at github.com/Nordic Semiconductor. So just a quick intro to nRF Connect SDK. It is all in one place. It is one code base and toolchain for the nRF 91 series, nRF 53 series, and nRF 52 series. It is optional for the nRF 52 series, so there you can either choose to use the nRF Connect SDK or the nRF 5 SDK. And this is since the version 1.3.0 tag that you can use the nRF 52 series and nRF Connect SDK. Protocol support-wise, we have LTM support, narrowband IoT, Bluetooth, including Bluetooth Mesh, Thread, Zigbee, and also GPS. And the version 1.4.1 tag introduces a Bluetooth version 5.2 qualified host and controller. When it comes to the nRF 52 series SDK support, the nRF 5 SDK is very good if you do not require a real-time operating system. Also, if you're used to this SDK and don't require newer features after Bluetooth 5.0, Bluetooth Mesh 1.0.1, Thread 1.1, or Zigbee 3.0, release 22, it might be a good idea to go with the nRF 5 SDK. The nRF Connect SDK support is optional for the nRF 52 series. We will support newer features after Bluetooth 5.0, Bluetooth Mesh 1.0.1, Thread 1.1, and Zigbee 3.0 release 22 in nRF Connect SDK. So yeah, for the nRF 52 series, you do have the option. On the right-hand side, you can see you have the option of using the nRF 5 SDK. You can use the nRF 5 SDK for Bluetooth Mesh, nRF 5 SDK for Thread Zigbee, or nRF Connect SDK. So depending on which use case you are, you will need to make a choice if you want to use nRF5 SDK or nRF Connect SDK. And please, see the documentation or the webinar for more information. I think in general, if you are starting a new design, it is more useful to use the nRF Connect SDK. Code-base wise, this includes app code, connectivity protocols, wireless stacks, and peripheral drivers. As you can see from the figure on the right, we have some code which is blue and some that's purple. The blue code is the Nordic specific code. So that's code that we write ourselves, and the purple is open source code, such as the Zephyr RTOS, for example. So the code is organized into 4 main repositories. So you have the nRF repository for applications and connectivity protocols, nRFXlib, which contains peripheral drivers and stacks. It also contains RTOS agnostic libraries, so RTOS independent libraries, basically. Zephyr includes the real-time operating system and also some board configurations, such as device tree, for example. And then you have MCU boot, which is an open source secure bootloader. So here's just a quick intro to some of the basic terminology. Git is essentially, you're probably well aware of what Git is. It's an open source distributed version control system for managing source code changes. This is very useful, seeing as we do have multiple repositories. So Git makes it very easy to figure out which tags and which commits fit together. West is a Zephyr specific tool, and it's a command line tool for multi-repository management and also building and flashing examples. So with Git, you can choose which tag you want to check out, and then you can use West to then basically update all of the other repositories to use the correct commit for that tag. Repository is essentially a version controlled project folder, for example, nRF or Zephyr. And every code commit creates a repository version with a unique secure hash algorithm identifier. Tag essentially just points to a specific commit SHA identifier. It is immutable, so it doesn't change. And the main difference between a commit and a tag, or one of the main differences, is that a tag is human readable. So instead of being a jumble of some random identifier, it could be, for example, version 1.5.0. That's a lot easier to read. And for a tag, Nordic product development support is available, but I'll talk a bit about that later. Master branch points to the most recent commit SHA, and that's mutable. That's always changing. So that's always pointing to the most recent commit. And master branch can be used if you want to start testing newer features earlier on, for example. Source code and configuration, just a quick intro to that. West, like I mentioned, is a multi-repository management tool that can be used for cloning and updating. So here you have the code base, the nRF Connect SDK code base, and then you can add your code in a separate repository. That then becomes the code base, dependent on the west.yaml file. Then you can use kconfig for source module and feature configuration. So there you can set the different features. For example, if you want to use GPS, for example, if you want to use MQTT, etc. You can set all of the different features in kconfig. And this can then be done without changing any of the source code itself. So this can easily be done in a project config file, for example. And then last but not least, you have the device tree, which describes the board target itself. So that's how you configure the target. So the device tree files, they'll be different, slightly different depending on whether you're using a Thingy91, for example, an nRF52 dev kit, or a mouse reference design. Release cycles. So nRF Connect SDK is released on a quarterly basis. It is publicly hosted on GitHub, and fixes are released as needed. So even if it's a long-term supported release, it can have fixes applied and delivered after new releases. And the latest development version is available, so that is the master branch. And version control management is done with Git. So if you want to manage new versions and also fix adoption. And the tool also supports merging. So we do have both major tags, minor tags, and also bug fixes in addition to the master branch. So just a quick intro on what is supported for development and what is supported for production and what that means. So features that are supported for development can be used for development, but are not recommended for volume production. So tech support is available. Reported bugs may not be resolved until it is supported for production. Implementations could be partial, and APIs may change, also going to production, and verification is incomplete. So this is very good for prototyping and evaluation. Features, on the other hand, that are supported for production will be maintained and are also suitable for product development. Again, tech support is available. Reported critical bugs will be resolved in both the master and latest tag version of nRF Connect SDK. The implementations there are complete, and this is verified for product development. So this is very useful for production. So it is suitable in end products. So just a short intro to the nRF Connect SDK documentation. I've provided a documentation link. You should be able to click on that once we in the PDF, which will be provided after the webinar is done. So the documentation page on the left-hand side, you'll see in the top left-hand side, you'll see a place where it says nRF Connect SDK and then the version. If you click on that little arrow, so the arrow here, you should be able to, then this will lead to a sort of an expanded menu down here where you can see all of the latest tagged releases. So all the way from version 0.30 to the latest one, which is 1.6.0. 1.6.9.9. So if you click on this latest box, that refers to the master branch. And here you can see the latest tag is 1.6.0. So don't confuse latest with latest tag. Latest refers to the master branch. And on the bottom left-hand corner of your screen, you should be able to see this box here. If you click on the arrow again, it will expand, and that's how you can switch to the different documentation for the other repos. So for nRFX, nRFXlib, Zephyr documentation, MCU boot documentation, and kconfig documentation.
Hello, my name is Krzysztof Loska. I work as a technical product manager for short-range wireless, and today I would like to present you exciting new features regarding short-range wireless protocols in nRF Connect SDK 1.6.0. The nRF 5340 SoC is our flagship SoC for short-range wireless. It includes a superset of the most prominent nRF52 series features. It is the first SoC in the nRF53 series and is the world's first wireless SoC with two ARM Cortex-M33 processors. The application processor is optimized for performance and allows you to perform time-critical application tasks without being affected by radio stack execution. The network processor is optimized for low power and efficiency and responsible for radio operations. The two processors and advanced security features are a great starting point for your application. With the capabilities for Bluetooth LE, Thread, and Zigbee, the nRF 5340 is a multi-protocol powerhouse. Additionally, nRF 5340 provides the advanced feature set and an operating temperature up to 105 centigrades. Combination of those features makes it the ideal choice for LE audio, professional lighting, advanced wearables, and other complex IoT applications. In December 2020, we released a production version of nRF 5340 available now through Nordic's distribution network. While for nRF 52 family, you have a choice which SDK to use. You can either use nRF5 SDK or nRF Connect SDK. nRF 53 family is supported only in nRF Connect SDK. nRF Connect SDK version 1.5.0 introduced production support for nRF 5340 for Thread in single protocol configuration. In version 1.6.0, nRF Connect SDK introduces for the first time production support for nRF 5340 for Bluetooth LE in single protocol configuration and in multi-protocol operation with Thread for Bluetooth peripheral role. It also delivers for development support for other short-range wireless protocols. Bluetooth direction finding is the major feature of the Bluetooth 5.1 core specification. It is designed to enhance location services where previously only signal strength-based technology has been used with received signal strength indication or RSSI. Bluetooth direction finding offers new and improved use case for real-time location systems for asset tracking in a wide range of scenarios from logistics and warehousing to value asset security in hospitals and factories. It also brings added user experiences in proximity-based scenarios for consumer awareness and contextual information. In nRF Connect SDK 1.6.0, we added 2 samples demonstrating the direction finding feature based on periodic advertising, available for nRF 52833 development kit. These examples are direction finding connectionless locator, which demonstrates Bluetooth LE direction finding reception, and direction finding connectionless beacon, which demonstrates Bluetooth LE direction finding transmission. Samples supports 2 direction finding modes, angle of arrival, AOA, and angle of departure, AOD. By default, both modes are available in the samples. Apple Find My Network accessory program opens up the private and secure Find My Network to third-party device manufacturers to build products utilizing the service. So your customers now can use the Find My app to locate and keep track of the important items in their lives. Nordic has extended its software offering to include Apple Find My Network technology options. nRF Connect SDK 1.6.0 integrates Apple Find My supported for production. In addition to new products, Find My Network support can be easily added to existing Nordic Bluetooth LE-enabled devices. This means you can incorporate Find My functionality into your wireless end products without major changes to form factor or design. Apple Find My members can get access to the Find My repository by contacting us via a Nordic DevZone private ticket. nRF Connect SDK is Nordic's default solution for HomeKit today. It supports creating both HomeKit over Thread and HomeKit over Bluetooth LE accessories. nRF Connect SDK 1.5.1 was the first nRF Connect release supporting HomeKit for production. It integrated Apple's HomeKit accessory development kit version 5.2. In nRF Connect SDK 1.6.0, we integrated Apple's HomeKit accessory development kit version 5.3 and added development support for nRF 52832 and nRF 52833 for Bluetooth LE HomeKit accessories. In addition to nRF 52840, already supported for production for both options, Bluetooth LE and Thread. Similarly to Find My program, MFI licenses can get access to the HomeKit repository by contacting us via Nordic DevZone private ticket. In nRF Connect SDK 1.6.0, we added support for all Thread 1.2 mandatory features for routers and end devices. They are supported for development for the nRF 52 family. Thread 1.2 specification brings few low-power improvements. A major one is introduction of a new device type called synchronized sleepy end device, which is based on coordinated sampled listening mechanism. A sleepy end device, which is a default device type used for battery-powered Thread devices, has its radio turned off during idle periods and wakes periodically to communicate with its parent router. Because sleepy end device is not synchronized with its parent, it has to communicate with the router to find out if the router has any data for it, even if there is no data. A synchronized sleepy end device introduced in Thread 1.2 further improved energy consumption. It has its radio turned off during idle periods and wakes periodically to listen for messages from its parent at scheduled intervals. Because synchronized sleepy end device and its parent router are synchronized, it does not have to communicate with its parent to find out if router has any data for it. As a result, synchronized sleepy end device activity periods are shorter than sleepy end device activity periods, and if there is no data coming from the router to synchronize sleepy end device, there is no radio activity at all. Project Connected Home over IP, or Project CHIP, was recently rebranded and got its final name Matter. Also, governing body of the project, Zigbee Alliance, rebranded to Connectivity Standards Alliance to reflect a change in the alliance mission from being an organization focused on Zigbee protocol and related technologies to an organization harmonizing technology standards across the IoT industry. The goal of Matter is to unify smart home by specifying a new application layer running on top of IP, Internet Protocol. Version 1.0 of the specification targets Wi-Fi and Thread as main connectivity protocols. Bluetooth LE is used for commissioning of new devices. The project involves engineers from Amazon, Apple, Google, Samsung, and over 180 other companies collaborating together to simplify development for manufacturers and increase compatibility for consumers. Nordic is an active participant in Matter from day one and provides full support for the project for suitable SoCs within nRF 52 and nRF 53 families. The project is still under development with the goal of being ready for production at the end of 2021. In nRF Connect SDK 1.6.0, we updated the Matter fork to recent revision and updated associated samples. This release adds several important functionalities comparing to the previous release in nRF Connect SDK 1.5. The persistent storage feature, which allows Matter devices to successfully communicate with each other even after reboot. Support for Open Thread Service Registration Protocol to enable the discovery of Matter nodes using the DNS-SD protocol. Support for Network Commissioning Cluster used when provisioning a Matter node. Message reliability protocol for the UDP traffic within a Matter network, and finally support for operational credentials cluster used to equip a Matter node with an operational certificate. We also added a new comprehensive user guide about configuring Matter development environment. It describes in details how to run a Matter accessory on a Nordic development kit, what are types of Matter controllers, and how to set up them together with a thread border router. nRF Connect SDK 1.5.1 features production support for Zigbee for nRF 52833 and nRF 52840 for the first time for nRF Connect platform. We certified the Zigbee solution present in nRF Connect SDK 1.5.1, so you can inherit Zigbee platform certification for your Zigbee product. In nRF Connect SDK 1.6.0, Zigbee is supported for development and should not be used for production purposes. Regarding single SoC architecture, the entire ZBoss Zigbee stack was delivered as a precompiled library in previous releases. From nRF Connect SDK 1.6.0, the application layer part of ZBoss Zigbee stack is available in source code. This provides great flexibility to developers and the ability to quickly expand or supplement the solution. Edge Impulse is a development platform that can be used to enable embedded machine learning on nRF Connect SDK devices. You can use this platform to collect data from sensors, train machine learning model, and then deploy it to your Nordic semiconductor device. In nRF Connect SDK 1.5, we introduced support for Edge Impulse machine learning models. In nRF Connect SDK 1.6, we added nRF machine learning application, which is out-of-the-box reference design of an embedded machine learning using Edge Impulse. The application gathers data from sensors, forwards data to the Edge Impulse platform, and runs the machine learning model. It also displays results of the machine learning model on LEDs. This concludes part about short-range wireless. Thank you.
Okay, then let's take a look at the Cellular IoT updates. So I'm starting out with a small overview to give you insight into what parts of SDK and what libraries and modules are relevant when you're building your Cellular IoT application. So starting from the bottom, we have the modem firmware responsible for LTE-M stacks, narrowband IoT, and GPS. It is a closed source precompiled image that you can download from nordicsemi.com, and it handles everything up to and including TLS and DTLS. On the application core, we have the modem library, which is the interface for operating the modem. It provides you 8 generic sockets that you freely can use for UDP, TCP, TLS, DTLS, and AT commands. It also provides you with APIs and interfaces for GPS, assisted GPS, and also modem DFU. On top of that, we have a wide range of different internet protocols, ease of use utilities, libraries, drivers, and modules, aiming to make your application development as easy as possible. And on top of all of this, we have some application examples showing you how to do asset tracking, showing you how to use the various features that is part of our SDK. Then over to what is new in this new version of nRF Connect SDK. First out, we have support for the new modem firmware version 1.3.0. So this is a modern firmware that we released a couple of months back with a lot of new, cool and very useful power saving features. I highly recommend you to go and watch this webinar if you haven't already. On the modem library side, we have also added a new GPS API that is replacing the old socket interface. We have a PDN library now instead of the PDN socket, and we have support for release assistance. On the device management side, we have done updates to the carrier library. It's now called version 0.20.1. It adds more configuration options, and it's now possible to use the carrier library also together with a custom lightweight machine-to-machine server. Then on the other side, we have lightweight machine-to-machine stack, also in Zephyr, which is open source and easily available. This one has gotten a new client util library that makes inclusion of device management in a custom application very easy. On the photo download library, we've added some new APIs that makes it capable of retrieving the image type that's being downloaded. It can cancel a current downloading image. It can validate the image types before even starting installation. Then on the location side, we have added support for predicted GPS. So this is more or less the same thing as assisted GPS, but the main difference is that the assistance data you download is now valid for up to a week instead of 4 hours as the normal assistance. This enables you to save power in those use cases where you don't need to report your location back to cloud all the time. So we have added support for predicted GPS in the asset tracker firmware and application, and also in the assisted GPS sample we have. In addition to this, we have added what we call multi-cell location. It's more or less using information about the neighbor cells and the neighbor base station around the device. It's sending that to a cloud service that will do some algorithms and figure out the location of your device and send it back to you. For this, we have also added a location sample that can be found under nRF 9160. So here we have an example showing you what to expect. So this is a 17-minute drive in Trondheim to Buvika. It's reporting the neighbor cell information every minute. And you can see that this is a very low power location method that's very suitable for devices that is traveling over some distance. You cannot really get sort of street level meter accuracy, but you can expect around 300 meter plus accuracy. And you don't even have to turn on the GPS at all to get this location. Then on the security side, we have added more functionality around trusted firmware RAM. So it's now stamped as supported for development. It's using the CryptoCell runtime libraries. It has support for protected storage and also encryption of the stored data. And we have added various set of samples showing you how to use it. So there's this TFM Hello World sample. It's a wide range of different crypto samples in the SDK. And there's also a TFM integration samples that's available through Zephyr. So what is really TFM? In short, it's the reference implementation of PSA. PSA is a platform security architecture, and it's a recipe for building secure connected devices. It's mainly built for ARM Cortex-M processors, and it's really leveraging the ARM Trust Zone technology to separate between the secure and the non-secure parts of your application. TFM, it provides a highly configurable set of software components to create a trusted execution environment. This is achieved by secure runtime services like secure storage, crypto, audit, and attestation. And also, in addition to this, there's of course secure boot, and TFM ensures the integrity of runtime software and supports firmware updates. Then over to the nRF Asset Tracker. This is our end-to-end asset tracker implementation. It mainly consists of 3 parts. It's a firmware part, it's a cloud part, and it's a hardware part. So on the firmware side, it's the Asset Tracker version 2 application. It has now gotten support for Microsoft Azure and nRF Cloud, which is the default configuration. On the cloud side of things, we have a reference example. It's called nRF Asset Tracker, and currently it supports both AVS and Azure. And on the hardware side, it comes with out-of-box support for both the Nordic Thingy:91 and also the nRF 9160 development kit. Then in this release, we have also added support for ARM Pelion. This has been a collaboration with ARM, and we have integrated an ARM Pelion client example. This example works with both cellular and the nRF 9160, but it also works with Thread. And it's more or less using the embed cloud client library as an external dependency. So if you're interested in this, check out the user guide in the nRF Connect SDK documentation. In addition to this, we have added a new application, a test application that we call Modem Shell, or MOSH for short. This is more or less the Nordic modem team's own test application that they use when they're testing new modem functionality. It uses the Zephyr shell to provide a command line interface that is easily scriptable for automated test environments. So if you're about to set up your own test environment, I highly recommend you to have a look at this application. It can help you to test connectivity features like link handling, TCP, IP connections, data throughput, SMS, GPS, firmware over-the-air updates, and everything. Then the other application we have is Serial LTE modem. Here we have done some, I would say, smaller updates to get all the different parts that we have updated. I recommend you to go through the release notes, and everything will be detailed there. Then taking a step back, we see that the nRF Connect SDK is a small part of the picture of what is really needed to build a complete low-power cellular IoT solution. First out, what we provide is the nRF 9160 with the included application processor and modem for narrowband IoT, GPS, and it really supports low power operations. Then under the nRF Connect umbrella, what we really offer there is the SDK that we have talked about today. We have nRF Connect for desktop, PC tools, used for programming device, used for getting logs, controlling AT commands. We have nRF Connect for cloud and mobile as well. And then on the kit and hardware side, we have 9160 DK, hardcore firmware developers, and then also we have a Thingy:91, more of a prototyping platform, including plastic enclosure and battery and these kind of things. Then I also want to mention all the cool tools we have for you to save power consumption and optimize power usage. First out, we have the online power profiler. It's basically an online tool where you can input your use case, your network. So you put in how much data you're sending, how often you're sending it, if you're using Narrowband IoT or LTM, you input different network parameters, and you will get a very detailed curve of the power consumption back, showing you how much power your device is expected to use in the different scenarios. In addition to that, we have a very good power profiler kit too. It's the hardware that you can use to physically measure how much power consumption your device is using. It's a very accurate tool for a very good price, I would say. In addition to these two tools, we have the power optimization guide, which is step by step taking you through what measures you need to do to make sure that your application is using as little power as possible. So with that, I strongly recommend you to fetch this presentation after the webinar. It will be made available to you, and all of the topics that I have talked through today, I've also added links to the relevant parts of our documentation for each of them. So don't hesitate to go through it and read more if you want to. Thanks, everyone.
So this is the last webinar in the program for the Mobile World Congress 2021, but all of the webinars will be available on demand. So I figured it was a good idea to show which webinars we have run. On Monday, June 28th, we ran a power optimization webinar with the latest features on the nRF 9160 system and package. On Tuesday, we had a cellular IoT coverage webinar with our cellular connectivity partner, iBasis. On Wednesday, we had a session on how the cloud helps your IoT devices get location data. So that's via assisted GPS, predictive GPS, and cell-based locationing. And today we had the exciting new features in nRF Connect SDK version 1.6. So like I said, all of the webinars are available on demand at webinars.nordicsemi.com if you missed them. And before we go to the Q&A, please sign up for more webinars at webinars.nordicsemi.com. If you have any more questions, feel free to get tech support and join our community at devzone.nordicsemi.com, and also find out more about our products and services at nordicsemi.com. So without further ado,